Hello, myself Dr. P. Kalyani, working as Associate Professor in the Department of Computer Science and Engineering of Institute of Aeronautical Engineering. In this video, I will discuss the definition and terminology of Module 5. This topic learning outcome is mapped with the course learning outcome of explain various testing approaches and automation tools. Differentiate top-down and bottom-up approaches. During integration testing, these two methods are popularly used. So, in the incremental approach, modules are added in ascending order one by one according to the need. The project is divided into small manageable units. Those are generally referred as modules. These modules, after unit testing, can be integrated so that they are ready for performing the integration testing. So, two popular approaches for the integration testing are top-down approach and bottom-up approach. So, here the selected modules must be logically related, and generally two or more than two modules are added and tested to determine the correctness of the functions. In this type of testing, there is a strong relationship between the dependent modules. The process continues until successful testing of all the modules. So, the first approach of integration testing is top-down integration testing. The top-down integration testing strategy generally handles with the process in which higher level of modules are tested with lower level modules until successful completion of testing of all the modules. So, major design flaws can be detected and fixed early because critical modules tested first. In this type of method, modules are added incrementally one by one and check the data flow in the same order. So, during top-down integration testing, the modules must be integrated at the high level. Consider this example. This module 11, module 9, module 10 are integrated first at the high level. Next, in the program architecture, the M8 module is integrated with this part so that this section of the project or the segment of the project code can be tested. Next level, the next tree level modules M6, M7 are considered, and later M1, M4, M5, these must be considered one after another in an ascending order starting from root level of the tree and continues until the leaf level of the tree. The advantages of top-down approach is fault localization is easier, the test product is extremely consistent, the stubs can be written in lesser time compared to the drivers. The stubs are generally simulate the missing module code. Critical modules are tested on priority. Major design flaws are detected as early as possible. The next variety of integration testing is bottom-up integration testing. So, in bottom-up approach, the testing lowest units can be started first and gradually moving up one by one. Here, testing takes place from the bottom of the control flow towards upwards. So, again, it's possible that the higher level modules might not have been developed by the time the lower level modules are tested. So, consider this example. Here, the lower level modules are first concentrated and are tested. those are integrated with the next high level. So all these modules are independently tested by the unit testing. Then they are integrated with M8, the next higher level of the module. So that after this, the next higher level M9, M10, like that, that integration process can be moved upwards. The advantages of bottom-up testing is the development testing can be done together, so the product will be efficient. Test conditions are much easy to create. The another variety of integration testing is the sandwich integration, which may generally combines the top-down as well as bottom-up approaches. So here in this type of integration testing, the system can be viewed as three layers. The main target layer in the middle, another layer above the target layer, and the last layer below the target layer. So top-down approach is used on the layer from the top to the middle layer, and bottom-up approach is used on the layer from the bottom to the middle. So Big Bang approach is used for modules in the middle. So consider this example. Here three layers must be there, the middle layer, and the upward testing must be carried out with the top-down approach, and the downward testing must be carried out with bottom-up approach. The middle layer modules must be tested with Big Bang approach. The advantages are top-down and bottom-up testing techniques can be performed in parallel or one after the other. Very useful for large enterprises and huge projects that further have several sub-projects. What is software? So, define what is the dual role of a software. Software can be viewed as collection of programs, the data structures, and the documents in the software engineering perspective. It can generally serve for two roles. One is as a product, second one is as a vehicle to deliver the product. As a product, it delivers the computing potential across the network of hardware. It enables hardware to deliver the expected functionality. As a vehicle to deliver the product, it produces system functionality, controls other software, helps to build other softwares. The characteristics of software are generally, when compared to the hardware, software is developed or engineered, but the hardware must be manufactured in the classical sense. Software does not wear out when continually using the software, but software is custom built according to the user requirements, but hardware is assembled from the existing components. So the difference between the top-down and bottom-up integration approach is, in this approach, the focus is on breaking up the problems into smaller parts, and in bottom-up approach, it solves smaller problems and integrated it as a whole when complete the solution. Mainly used by structured programming languages like COBOL, Fortran, C, etc., the top-down approach. But in case of object-oriented projects, the bottom-up approach can be useful. Each part is programmed separately, therefore contains redundancy. But redundancy is minimized in case of bottom-up approach. In this, the communication is less among the modules, but here more among the modules. And the debugging of module documentation is also used for the top-down approach, but basically used in the testing the bottom-up approach. In top-down approach, decomposition takes place, but in the bottom-up approach, composition takes place. So in the top function of the system might be hard to identify, but here to build a program from the piece, so we can start it. In this, implementation details may differ, but naturally for people to assemble. Define software testing methods. Three methods are majorly used. One is white box testing, second one black box testing, third one grey box testing. The white box testing is predicted on close examination of procedural details. So the structure and the syntax and logic of the program is considered in the white box testing. Logical paths through the software, collaborations between components are tested by exercising specific sets or conditions and loops. White box testing is based on the application's internal code structure. White box testing, an internal perspective of the system as well as programming skills are used to design test cases. In the black box testing, in this method, the tester evaluates the functionality of the software under the test without looking at the internal code structure. So it is also called behavior or specification based testing or input output testing. Black box testing alludes to tests that are conducted at the software interface. Grey box testing is combination of both white box and black box testing. The tester who works on this type of testing need to have access to design documents. It helps to create better test cases in this process. The comparison of testing methods, the black box testing, the internal working of the application need not be known, but here the few implementation details are required in grey box testing. White box testing is the logic based testing. The program structure is considered for the testing. So here the black box testing alternative names are closed box testing, data driven testing or functional testing. So the gray box testing is transparent testing and tester can have the knowledge of the program also. And also here the white box testing is the clear box testing performed by the end user with the black box testing. But gray box testing is performed by the testers and developers. Normally done by the testers and developers, the white box testing also. Testing is based on external expectations, internal behavior of the application. The user interactions are majorly concentrated in the black box testing. But in case of gray box testing done on the basis of high level of database diagrams, data flow diagrams, the process flow can be verified. So the internal working of the fully knowledge according the program structure and the working of internal control structure, loop structures are concentrated in case of white box testing. So the least time is consuming in case of black box testing, partially time consuming, but exhaustive time consuming is in case of white box testing. The black box testing is suited for algorithm testing, but gray box testing is not suited for algorithm testing, but white box testing is suited for algorithm testing. This can be only done by trial and error method, but gray box testing is data domains and internal boundaries are identified in case of gray box testing. Data domains and internal boundaries can be better tested in case of white box testing. Define the basis path testing. Basis path testing is a white box testing technique based on the programs or modules control structure. A control flow graph is created using this structure and many possible paths in the graph are tested using this structure. Because this testing is depending on program's control structure, it necessitates a thorough understanding of program structure. The importance of basis path testing is to examine the code base to identify all possible paths that could be taken by the user to achieve their aims. So during the program execution, the starting point of the program execution until the end point, what are the alternative paths of the program flow can be identified, and test cases must be written to guarantee and exercise each independent path. These paths are then written as test cases to ensure all different identified scenarios in the main branches are covered. So higher test coverage is then achieved when test cases are executed, typically through a form of unit testing. So the tester established a baseline by selecting the most critical, common or obvious path through the code selection. The steps of test case design: create a control flow graph, calculate the graph's cyclomatic complexity, identify paths that are not connected, create test cases based on the independent paths. What is unit testing? In software application, the smallest part of the code that can be tested is called the unit of the code. Unit testing is testing method used in the software development cycle to validate a unit of code will behave as intended or specified in the SRS, that the test code will produce the same result every time the test is performed. Unit testing comes under white box testing and is generally done by the writing test cases, exercise individual functions, methods, and classes. Unit tests are normally written in pseudocode. General unit testing life cycle is: check the code repository and make the changes if possible, execute the unit test and find any defects are there, and code review, check the code into the repository. The advantages of unit testing is early detection of problems in the development cycle, reduced cost, trust-driven development, more frequent releases, enable easier code refactoring, defects changes which may break a design contact, reduced uncertainty, documentation of system behavior. The general unit testing techniques are structural unit testing, functional unit testing, error-based unit testing. Variety of unit testing tools are available. They are NUnit, JUnit, PHP Unit, Parasoft JTest, EMMA. What is system testing? System testing is also known as end-to-end testing. It is a type of software testing that verifies that system works as intended. So when after the integration testing, when whole system is developed, then testing that entire application by giving required input and giving the events to activate the stimuli and what are the valid requirement, and observe, verify the expected outcome is produced or not. It is performed on a complete software system after integration testing before user acceptance testing. The system testing is generally identify the defects of misuse of system resources, unexpected combinations of user level data, incompatibility with the environment, unexpected use cases, missing or incorrect functionality, the inconvenience of use. The objectives of system testing are reducing the risk for bug-free components and as well as preventing as many defects and critical bugs as possible by careful examination, verifying the conformance of design, features and performance with the specifications stated in the product requirements, and validating the confidence in the system as a whole before moving to the final stage. The acceptance testing is the final stage of testing. So before user get access to a product, the testing must be completed. The system testing process generally carried out the test definition and planning the test procedure, whether to use automation or not, how to test case designing, next test execution, test automation, and bug testing, fixing, and report generation. The types of system testing are generally the performance testing, usability testing, load testing, regression testing, migration testing, functionality testing, scalability testing, recoverability testing. Generally, the non-functional requirements are more concentrated in the system testing. What is manual testing? The process of checking functionality of an application as per customer need without taking the help of automation tool is known as manual testing. While performing the manual testing, any application software test engineer do not need any specific knowledge or any specific testing tool. Rather than having a proper understanding of the product for preparation the test document. Define software re-engineering. Software re-engineering refers to updating the existing software without changing its functionality. The code is rewritten and the software design is changed during this process. Software re-engineering is a process of software development that is done to improve the maintainability of the software system. The need for re-engineering is reduce the technical debt, improve performance, add new feature, migrate to new platforms, reduce maintenance cost. The objectives of re-engineering is the primary goal of software re-engineering is to improve quality and maintainability of the software system while minimizing the risk and cost associated with the redevelopment of the system from scratch. To describe a cost-effective option for a system evaluation and distinguish between software and data re-engineering to explain the problems of data re-engineering. So, in the re-engineering process, the source code for transactions from the original program is considered and reverse engineering, so program documentation, program modularization and program structure and structural program must be considered. After that, the modularized program must be given to the data re-engineering. So the original data can be fed and re-engineered data can be modified. The approaches of data re-engineering is data cleanup, data extension and data migration. So the re-engineering model generally concentrating on the inventory analysis, document restructuring, reverse engineering, code restructuring, data and forward re-engineering. The cost drivers for the re-engineering are the quality of the software to be re-engineered, the tool support available for re-engineering, the extent of required data conversion, and availability of expert staff for re-engineering. The factors that can affect the re-engineering cost are size and complexity of the software, the number of features that can be added or modified, the tools and technologies used, availability of documentation, team size and skill levels, testing and quality assurance, post-deployment maintenance. The advantages of re-engineering is reduce the risk and cost, the revelation of business rules, better use of existing staff, increased competitiveness, increased innovation. The disadvantages are disruption to business operations, difficulty in measuring success, difficulty in maintaining continuity, lack of employee involvement. So these are the definitions that covered from the module 5, that is belonging to the software testing, and the references used in this video are this. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.